give a warm welcome to Mr. Ajaz Kazi. Mr. Kazi is currently Execution Head MEP at Reliance Industries. His project management professional with more than 2 decades of experience in handling MEP projects across Maharashtra, Goa and MP for applications such as offices, hotels, hospitals, malls, airports, power, refinery, pharmaceuticals and many more. With a mechanical engineering degree, he holds a postgraduate diploma in material management from IIM Bangalore and a PMP certification from PMI USA. Mr. Kazi's contributions span over ISHRAE as President, Mumbai chapter and ASHRAE as Vice President, and currently Mr. Kazi is National Chair for Research Promotion. He has also published 2 books. His impactful career signifies a transformative force in infrastructure development. Today, Mr. Kazi will share his insights on energy efficiency for HVAC systems. So please welcome Mr. Kazi.
So what I'm going to do is, I'm just going to run through the PPT here, but I'm going to get into the basics, and that's what we started. Everybody knows HVAC system is an energy guzzler, and you can say around 50 to 60%. This is the data for commercial buildings, is the energy which is consumed by HVAC system. And that's why it becomes more and more relevant. If you do this, I think majority of other things can be managed. So this is where I think we are going to look at, and that's what I said. Let's go back to basics, because most of the time we are saying that this product is fantastic. It has got a 6+ COP. This AHU is a fantastic smart AHU. This will save this AHU, this many units of your power consumption. All these things are happening in the market because yes, everybody wants business, and there are some marketing gimmicks which people do it, but we forget the basics. And that basics, if it is not laid properly, or the foundation is not laid properly, whatever cosmetics things if you want to do it, we can only become good for some time. Then the makeup goes and we come back to the original shape again. So let's not go to that, and that's where my presentation is based on. HVAC system, first thing comes is your design. If you are in design engineer, the system calculations have to be proper. The system calculations, the data input which comes from the customer has to be properly understood. Whether the customer has got all those important things which can save the HVAC load, that data we need to get it from the architect or from the stakeholders who are involved from the customer side. There are a lot of stimulation technologies which are there, the software-based technology, which will give you something like digital twin. So I am building a new building. I create a digital twin of that building. I do a performance stimulation with respect to its orientation, with respect to various areas where the artificial sensors are put and the performance is evaluated. So there are various companies who do a right kind of stimulations. Majority, if you look at Bangalore airport, it was built on the similar technology where they stimulated the entire thing first before building it real. The system calculations, there are good software which are available. There are various drawings which we can do on 3D. That will also help. So before we get into the execution mode, we know what we are going to do, and what are the problems which we may face. Those are anticipated, proactively, so that we don't face the problems later. So system calculations are important with the right inputs, the right kind of glass, the right kind of material which they are going to use, which will save the load inside them. So various softwares we can use. Then selection of equipments. The individual HVAC system, we've generally given experience to the people who are there in this building. So selection of equipments becomes an important item where all the selections are properly done for my need. For me, my need is to maintain 26 to 27 degree. The selection of equipment could differ from those who want to maintain 22 degree, right? So we need to understand what is the customer requirement, select the equipment, not the costliest one, not the complex one, the easiest and the best suited for that application. That needs to be done. Most of the time, we go for high-fly, complex machines. They don't work in the end. Then the design of low-side systems, where the ducting, the piping, how best efficient piping can be designed with less of bends so that there is no pressure drop. That pressure drop will again act as a head to the pumps that will again have more power consumption. Similarly, inducting, how simple we can design, so there is no pressure drop, so there is no static pressure applied on the fan, and how can we save the energy. These are small things which we need to look at. When we look at energy in the center, then all these things will fall down. But when we don't look at the energy in the center and start designing, we'll only do a over designing. We'll not do a right designing. Integration of components, we have seen this. Every component must talk to each other, because this is a system. If the system, as a system, it doesn't work, your individual equipments, best of equipments will not help. So integration, how we can we do, how they can talk to each other. Always look at for optimum and simple design rather than complex design, and effective building automation system. This is a must, because if you are not able to get data, we will not be able to take action. Building automation system powered with AI can do both things. It will also give the data, and it will also give the right instruction to the equipments when to perform. It's like similar to an occupancy sensor. When the occupancy is there, your light will come out. Similarly, when the occupancy is there, the air conditioning will get in. Such systems will help, and that, as I said in the beginning, the design of HVAC and the automation design has to go hand in hand right in the beginning. We don't want to do the experiment later. The next come, if I do a good design, a great design, not installed properly, it will have direct consequences on energy consumption. Best installation, right commissioning will give you optimum energy consumption, and that is very important. The design, it doesn't end at the design, right? Otherwise, we do like this. You can see the photograph here. This is the best installation we can see in the industry, right? This is one good example. When you have multiple chillers, what is the distance which we need to keep from this wall of the building so that there is no heat effect there? That heat effect will have huge impact on the energy efficiency. When we have multiple chillers together, again, there has to be proper distance which needs to be done. Otherwise, again, we'll have a heat effect. You can see over here, the red ones are the ones where, and your compressor will start overworking. Everything will finally end at the energy consumption. We need to also look at how do we keep the system and the space for maintenance. Similar to this, in water-cooled chillers, we need to have a tube cleaning, to be done properly. We need to keep distance, safe distance for doing this. Otherwise, we install the machine, there is no space to do this. Your coils will get, impacted, and when the heat transfer efficiency comes down, your power consumption goes up. Everything is related to, again, power. Or we install systems where automatic tube cleaning can be done. It's a part and parcel of integration of the system. If we add it later, it may not give that much idea. It will give, yes, but if you install it from the beginning, our planning has to be for the energy efficiency. So these are some of the aspects. Similar to cooling tower, it has to be having no starvation of air. If we have a starvation of air, cooling towers will not perform. Your energy efficiency will be in problem. So right now I'm talking about the execution strategies. Look at this. You see a cooling tower over here. It is completely enclosed. We have very less heat transfer. We can see here a cooling tower. The top of that is a slab. Where the heat will go, it will come back again. It will short circuit. So these are some of the live examples. Live photographs will tell you how do we install the systems, right? Similarly, pumps. How do we install pumps? There has to be a checklist. This checklist will tell you the right installation practice of the pumps, because pump is also an energy guzzler. It has a motor, right? Similarly, fans. You must follow the guidelines for fan installation. Generally, they are given by the manufacturer. We don't read. We install like this. If you look at this fan over here, correct installation. This will create turbulence. When it creates turbulence, it will impact the power consumptions. So these are given, if you look at the axial fans over here, which is the correct way of connecting axial fans, which are the incorrect way of doing the axial fans. These are some of the things. VRF system, it has to have an open air for their outdoor system. Otherwise, you will have problems. Look at this VRF system. system is put, somebody has put a staircase on top of it, there is no heat transfer which is happening, and it is stripping, it is consuming more power. So this is an again issue. Again, a guidelines for VRF systems from the walls, what is the distance they have to keep. If you have multiple units, what is the distance which has to keep? These are given by the manufacturers. We miss and we do it as per our own way. Ducting. What kind of ducting? What are the fabrication standards? How do I make my duct leak free? Because anything which is going out of this duct is again an energy, right? Because air is passing, it's going at velocity. It is the energy. So any loss, how can we save the loss is again an important aspect. We can do a test of ducts, then we can have, there are a lot of guidelines which are given, like SMACNA, there are EU standards, which will tell you what is the minimum leakage class, what is the minimum leakage CFM which is acceptable. We must strive to achieve this leakage class. Otherwise, any leakage is more than that will have direct impact on efficiencies. Like there are various ways, like the masking tapes or a sealant, or there is a good system which is now coming in, which has got aerosol products which goes inside the ducts, and they are going into high velocity. If they find any opening in the duct, they will try to get out of the duct, and when they try to get out of the duct, they stick there for a long time. They say it is 15 years plus, they will stick there. That means the leakage will stop. So these are some of the technologies which we can use to have less, air leakage. One of the important thing which I have faced in my life is this: my termination of collars, duct collars to the grill. There is a gap. The air goes right into the return air. Your ceiling is more cooler than the area which is supposed to be cooled. This way, if you put a proper grid work, ask from the interior contractors, terminate the collars properly, you will save a lot of energy. Otherwise, you look at this collar, there's a gap. This collar is behind. This collar is ahead. Look at these collars. These are some of the issues which we tackle day in, day out. Look at this flexible installation. You will definitely have huge impact on the air circulation as well as the power consumption to push the air through this. This is not the way to install. This is the way to install flexible ducts. So we actually misuse the products. And then look at these pipes, U-bends over here. Look at these pipes. Again, these are some of the things I thought photographs will get more attention, more learning. So that's what I got, some photographs on field. Insulation is another important thing. Insulation is done to avoid the condensation and to reduce the energy. We need to look the holistic way, how do we insulate? Otherwise, you can see over here, insulated pipes. You can see a water like rain over here. You can see water like rain. Just look at this. This is one of the parking. The pipes which are insulated, sweating. Sweating is one way you are losing the energy. See the current installed, some of the photographs. Insulation not done properly. You can see no adhesive. You will have issues. This is the way you have to do insulation of ducts. Look at the way it has been done. So there are ways of doing it. It is only the supervision and the will to do it, right? Once we do this, we need to commission the system. We do what we do. Tomorrow is the inauguration of the building. Today I start commissioning. The commissioning approach has to be different. Commissioning approach has to be not like this. You can see the reality is here. How do we measure the temperature, area temperature, and what is reality? These are some of the questions. As Dr. Vishal said, we need to be more aware. We need to start training people. Commissioning has to be done to meet the owner's project requirement. If owner wants this system has to be this energy efficiency, we should be able to demonstrate by doing a right commissioning. It actually gives an assurance that whatever the system is designed, it is maintained accordingly. So commissioning plays an important role. You can see design intent, construction, finally be commissioned, and then we get a lot of feedbacks. That feedbacks can help you to fine-tune your systems in design, in construction. Commissioning is helpful for economy, for energy efficiency, because this, if you look at here, any building, the occupant is happy because it is rightly commissioned, his comfort levels are maintained. The employer is happy because once you have right atmosphere, the productivity goes up, and the owner of the building is happy because he gets a proper rent. So entire equation fits if we perform the commissioning properly. Most of the time, we don't do this. If you look at here, owner, he invested building. If it's a good building, he will have less sick leaves, high productivity. If he rent out to another tenant is also happy, and he also can pay a little higher premium to the owner. This is where the commissioning is done. Commissioning has to start, as I said, from the pre-design, to the design, to the execution, then to the occupancy and operation, and it has to be ongoing. It cannot be at the end of the project where I switch on the machines are commissioned. That's the approach which we have currently in most of the areas. We need to change, we need to involve commissioning team right in the pre-design stage. And that's a mindset change we have to add. People will say that we are adding a resource, it will have cost, but that cost will give you a payback. Very, very important. Commissioning has to be an integrated approach. It is like this maestro who has got music players. The music comes out is a different music, integrated music. Similarly, the approach has to be integrated, and this is very important. One of the example is VAV. We install VAV to save energy because VAV will operate only when there is a load in the room. But it is working like that. Is it commissioned like that? If it is not commissioned like that, then VAV becomes a piece of a duct which has no meaning. As I said, we install all these high fancy equipments, not installed, not commissioned properly. It's a fantastic equipment, but if it is not installed, not commissioned, and not maintained properly, it will not give an output. One of the important thing in commissioning centralized system is this flushing. Right quality of water has to get in. Look at this first quality of water and what we need. This has to be, again, it will have huge impact on energy efficiency. This is added with controls for monitoring status of sensors. How do I schedule my equipment? Start, stop. What are the set points? What are the trends? And how do I optimize based on these trends? Is the way we can use our brain to get this data, to get the right sensors calibrated, properly schedule it, and get these data trends that will help you to optimize. This has to be an ongoing process. Controls will be able to help you to get the data and also to control. Only thing we have to put our mind and give the right logic to the control system. It will work definitely. Then it ends with operation and maintenance. Again, first goal has to be energy efficiency, equipment lifespan, indoor air quality, and that all will lead to cost saving. Operation guidelines, proper temperature humidity control. Don't make it 22 degree or 20 degree, unnecessary. It has to be the right temperature, right humidity. Setting of thermostat schedules. We can do with smart thermostat all the scheduling. When the meeting room is off, you just want a ventilation, run the thermostat at 28 degree. When the meeting comes up, make it 24 degree. How do we optimize the airflow? Just don't start blowing the air everywhere. Blow the air where it is needed. The underfloor air conditioning which is coming in, where they cool where it is required. Rest of the area is not required to be cool. And this is where the mindset has to change, the design has to change, the implementation has to change. We need to prevent the excessive load on the system. This can cause from non-cleaning of the filters, one of the important aspects. Don't clean, it will overload. It will start affecting the energy efficiency. Refrigerant leaks. Again, somebody said about the greenhouse emissions. We need to have the leak monitoring system so that we can tackle it. Routine maintenance of pumps. All these things will help you to maintain the system and maintain the energy efficiency. Cleaning of stainers, important aspect. Again, it will lead to energy efficiency. The belt check, small item in operation maintenance. Check the tension of the belt. If it is loose, you will consume a lot of energy. All these small things which I thought when I started. Let's go back to the basics. Cooling tower, spray nozzles have to be checked. If they are not flowing, look at the left-hand side picture. What is the status of cooling tower? Look at the right-hand side of the. Both are from the India. It is only that we need to push to get the right quality of water. Routine maintenance, as I said, the tube cleaning. Proper heat transfer can happen with proper tube cleaning. Routine maintenance will give you a lot of readings, a lot of data, data becomes an oil for you to take actions. Water quality, again an important aspect. We need to maintain this. I've seen out of 10 machines, 9 machines popped off. The water went inside the compressor because the water quality was not maintained. Again, I come back to the training aspect. The gentleman who was given responsibility to maintain the water quality was told that every day he has to come and add this chemical. The gentleman did right job of putting the right that much chemical daily basis. He did not check the water quality. He was only told to add the chemicals. He did his job. Finally, it landed 1000 TR into 9 machines, went off. All the floors were non-conditions for 15-20 days because compressor had to go to factory, repair, come back. Water quality is important aspect for energy efficiency. Now, some of the best practices in operation maintenance, regular inspection, oiling of the moving parts, checking refrigerant levels, calibration, because if you get right data, then only you will act. If the equipments are or the instruments are not calibrated, you will not get the right data. Again, your actions will be faulty, right? Cleaning and maintaining of duct work. One of the practices I said is the cleaning and duct leak arresting. Is that aerosol products? Regular cleaning. You can see that the diffuser over here on the right hand side completely clogged. The issue of health hazards are there, but it is clogged. It is important. You can see air condenser coil over here, not regularly maintained. It will have direct impact on the energy efficiency. This is what I wanted to conclude on. I'm available on all the social media platforms. Any questions, I'm happy to answer.
Thank you, Mr. Kazi, for taking up this topic. So we have few questions. We'll start with the first one.
How much amount of energy can be used EC fans instead of PL plug fans?
EC fans, they will definitely give you at least 6 to 10% more energy efficiency than the plug fans. From the belt driven, we have gone to the plug fans. We are direct coupled. Now the EC motors. They are definitely only issue is getting the delivery of these fans because these are all semiconductor based control, and most of the issues are with the delivery. But obviously they are far superior than the plug fans.
One person is asking, can you share your PPT?
I'll share it to madam.
Yeah, definitely. And one is very long question. We will put it in email to you that you can answer later.
Okay, no problem.
Yeah. Can you understand, please?
So one question is, what do you think about the scope of photovoltaic thermal heat pump systems in future?
Heat pumps are getting more and more popular, especially the areas where we don't need air conditioning for long period of time. People already started using it, and it will be more popular. I'm sure because it has got better efficiency than the regular compressors.
One question is, they have used PICV in one part of building and TVV in another. So what should they use in valve chamber to balance?
If you are using PIBCV, use it PIBCV. That's the only way to do it. We can't have multiple things. It is very difficult. Air water balancing is a very, very challenging stuff. When we started our career with the manual balancing, it used to take long time, and we never used to get perfect balancing. Use one simple consistently, and that will give the better result rather than experimenting.